what? Out of plane. Your XY plane now is your what? Your in plane. Because the surface area is the what? Biggest. So over here, this is your XY plane. Over here, this is your YZ plane. And over here, this is your, oh no, that is not your, this is your, yeah, this is your YZ plane. And over here is your XZ plane. Okay. And then we have another circle to draw. And this circle from point X, Z again, and it's over here. So it's 2, 4, 6, 6 and a bit. So it's 3 and a bit. Okay. So this circle belongs to your XZ plane, which is your out of plane. Ladies and gentlemen, meet 3D Mohr circle. That's it. Is it more difficult than 2D? You learn the most in what? 2D. 3D is just this information that you need to know. Yes. Yeah, you can calculate them, right? You can calculate your shear stress for your X, Y, Z plane. You can calculate your shear stress for your Y, Z plane. Right? Huh? Yeah, but because these circles over here has their own shear. Can you see that? All this, the other two smaller circle has their own shear. But it's not as big as the in-plane one. Yes. Say it again. Yeah. If they don't, but there is shear in the two smaller circles. There's maximum shearing stress.
Okay, so with this question, though, we won't be. There's no way we can.
Don't look at this question. Understand the concept first.
Right.
Don't just look at question. Understand the concept first, okay?
I understand that, but I just want to.
You can calculate that out. It's not difficult, right?
With this question.
Yeah. To calculate the shear is you know this value over here. You know this value over here. You add the two divide. You just this minus this divide by 2. You got the radius. Yes. Right? It's not difficult. Okay. So the next question that we're going to do 3D Mohr circle. Okay. And again, I will tell you this. It is not what? Difficult. Okay. So let's look at
Eugene.
Yes.
Would you please explain again, like how we find out why the like the inside circles are YZ plane and XZ planes?
Because of this angle over here. So if you look at point Y,
Yeah.
you look at point Y, right, to the principal stress, the angle over here is an acute angle, yes or no?
Yes.
Less than 90. So this circle over here is your what? YZ plane. So if at point X over here, this is also an acute angle, yes or no?
Yes.
Right? So this touch the Z and X, that's why it's your XZ plane. That's it.
Okay. Okay.
Okay, it is all based on the acute angle. Okay, that's why we label it that way. Okay, now the next question that we are going to do is one of the most complex question in Mohr circle. And how long you all learn Mohr circle? Less than 2 hours. You just need to apply what I teach you. You can solve one of the most complex question on what? In the textbook. Am I very good in selling ice in Alaska? Yes or no? Right? You can solve it. I will tell you that. It's not difficult. But if you look at the solution manual and solve it, good luck, you know. Good luck. Okay. So now I'm going to make matters worse. We're going to combine 3D Mohr circle with U strength. Right? How are we going to combine? And it's not difficult. And I better stop saying it's not difficult. I better demo. Okay. This is the question that we're going to do. Okay. Don't read the question. I'll explain to you what's going on. But before we go there, I want you to look at this question. You look at the equation they form. Can you see that? Can you look at the equation they form? Holy shit, yes or no? Then you look at the next page. Look at the equation that they form. Look at all this. Look at the equation. If you just look at the equation, I also give up. I'm going to solve this using what I taught you for the past 2 hours. Okay, look at the equation. I'm like, good luck. Oh. There's only one person that can figure this out. It's your math instructor. I can't do it. Okay, but I'm going to show you a method that's so easy to do. Okay, I think I should change my job to do telemarketing, you know. Okay, let's start from here. Okay, let's draw. So we have an element. I will explain the question to you. Don't read, okay? I'll explain the question to you. We have a 3D element. Okay. Giselle, Jonas, did I answer the question on how big the circle to draw or no? Not yet. Okay, so the student asked, how do we know the size of the two inner circle? So the inner circle will start from point Z. Okay, we'll start from point Z until it touches the bigger circle. Okay. Likewise, the other circle in the X Z plane is from point Z until this point that I highlight. Okay. Jazil, is that okay? I don't hear anything from him. Okay, he's okay. If it's okay, I'm okay. Okay. So 3D. So this question, it states that we are having tensile 14 KSI. And then we have a shear. I think the shear is what? I can't see. The shear is 8, right? We have a shear of 8 KSI. We have to find what is this value. And we are given tau max must be equal to 10 KSI. Okay. So these are the information that is given. Okay. So for this question, okay, we have to find what is what. What is stress Y? So stress Y, there are two possible value. Okay. Before I carry on this problem, today's class, we will go until 12:30. Okay. Now, watch this. Okay, watch this. Those of you have to go, you go. Okay, it's recorded. Okay, so how does this work? Yeah. So I'm going to show you 4 possibilities. 2 will be correct, 2 will be wrong. And I will tell you why it is correct and wrong. Okay? And I want you to watch this. Now, so the stress max, this is condition that must be always met. regardless, whatever solution we have, tau max must be equal to 10 KSI. It cannot be 9, it cannot be 8, it cannot be 7, it cannot be 6. It must be how many? 10. Okay, don't break the rule. You are very famous for that. Okay, it must be always be 10 KSI. Okay, so now I'm going to take this element and I'm going to call them X, Y, and Z. Okay, so I'm going to copy. I'm going to paste. Okay, so this is our point X, our point Y, and our point Z. Okay, so now we can construct our Mohr circle. So I'm going to draw this is our normal stress. Okay, so it is 14. I'm going to do mine. I'm going to do maybe -6, -4, 0, 2, 4, 6, 8, 10. You know what? I'm going to draw bigger. I want to show something. Okay, so the maximum is 10. Okay, so I'm going to draw this bigger. I do apologize. I'm going to make this big. I'm going to start from -20, 18, 16, 14, 12, 10, 8, 6, 4, 2, 0, 2, 4, 6. Maybe I was too ambitious. 10, 12, 14, 16. I think I'm okay. I'm going to make it big. 18, 20. Okay. And then this is going to be our 10. Our shear. Okay. So shear element rotate clockwise. Element rotate anti-clockwise. -2, -4, -6, -8, -10, -12, 2, 4, 6, 8, 10, 12. Okay. So I'll let you guys finish copying first, okay? I think I might need more than that. Yeah. I'll move some more. Okay. I think I need to. You guys don't move it. I need to move because I want to show more stuff that is important. (22, 24, 26). Okay. Okay. I'm going to draw a box. Okay. And this box is going to be this size. Okay. This is the red box. On this red box, it reads 10 in shear max. Okay, shear max is 10. Hey. Right? And the normal stress max is equal to 20. And likewise, the minimum stress over here is also minus 20. Now, why is that?